NASA has unveiled a new plan to reach the moon's south pole, partnering once again with Firefly Aerospace. So far, Firefly is the only American company to successfully land a spacecraft on the moon, achieving this milestone with their Blue Ghost 1 mission in March of this year. Landing at the South Pole has proven far more challenging. Another American company, Intuitive Machines, attempted to reach this region twice in the past 2 years and failed both times. By comparison, the Northern Hemisphere, where Blue Ghost previously touched down, offers relatively smooth terrain and ample sunlight, making it far easier to land safely. For this mission, NASA is entrusting Firefly with 2 high-value lunar rovers. The first, Moon Ranger, is being developed by NASA's MS Research Center in collaboration with Carnegie Mellon University. About the size of a carry-on suitcase, Moon Ranger is designed to autonomously explore the lunar South Pole in search of water ice. Its stereo camera system will generate detailed 3D maps of the surface, allowing it to operate fully autonomously, even without communication with Earth. The second rover, developed by the Canadian Space Agency, is a similar 4-wheeled, luggage-sized platform. This vehicle will also hunt for water ice while measuring radiation levels and temperature changes at the South Pole. Uniquely, the Canadian rover is solar-powered, but also has a battery capable of sustaining operations in the permanently shadowed craters for up to an hour, where large water deposits are most likely to be found. This design gives it the potential to survive the 14-day lunar night and resume exploration the next lunar day. In addition to the rovers, the Blue Ghost lander itself will carry 3 scientific instruments. The laser ionization mass spectrometer will collect regolith samples with a robotic scoop and analyze them using a laser to break the material down into atoms and isotopes for precise composition measurements. Blue Ghost will also carry NASA's stereo cameras for lunar plume surface studies, part of ongoing research into how spacecraft affect the fine, dusty regolith. Finally, it will be equipped with NASA's Laser Retroreflector Array, which allows Earth-based lasers to measure the lander's location with extreme accuracy. With these instruments and rovers, NASA aims to explore one of the most mysterious and scientifically valuable regions of the moon, the South Pole, unlocking clues about water ice deposits, lunar geology, and conditions that could support future human missions. NASA's South Pole mission is scheduled to launch as early as 2029 and will be the most ambitious test for Firefly Aerospace to date. But this won't be their only lunar mission this decade. Even before Blue Ghost 1 succeeded, NASA had already selected Firefly for additional commercial lunar payloads. The next mission, launching next year, will send Blue Ghost 2 to the far side of the moon, often called the dark side, though it isn't actually dark, just hidden from Earth. Blue Ghost 2 will first deliver a European communications satellite, Lunar Pathfinder, into orbit before descending to the far side. There, it will deploy the Lunar Surface Electromagnetics Experiment Night, which will perform radio astronomy using the moon as a shield to block Earth-based radio interference, giving scientists a clearer view of the early universe. Following that, Blue Ghost 3, planned for 2028, will investigate a puzzling region in the moon's northern hemisphere known as the Graphene Domes. Unlike most lunar geology, which is formed from thin basaltic lava that flows easily over the surface, these domes were created by thick silicate lava that flows like peanut butter and hardens into granite-like rock. On Earth, this type of lava only forms where tectonic plates collide in the presence of water, but the moon has neither, making these domes a mystery. Blue Ghost 3 will carry 6 scientific instruments, some mounted on a rover provided by an as-yet unnamed commercial partner. One particularly interesting rover design comes from Interune and Astrolab. Built on Astrolab's Flex rover platform, it is designed to locate and collect helium-3, a rare element with potential for nuclear fusion that could provide near unlimited energy for Earth. The rover will tow a resource harvesting device developed by Interoom. Before mining helium-3 on a large scale, the companies plan a test mission at the end of this year. The test rover will be delivered to the lunar surface by Astrobotics Griffin lander aboard a Falcon Heavy rocket for its first mission. Interoom's rover will carry a specialized camera developed with NASA to estimate helium-3 deposits. The rover will look for titanium-rich minerals, which are believed to correlate with helium-3. Once scientists have a clearer picture of potential deposits, Interoom plans a follow-up rover in 2027 to collect samples from the most promising sites. Interoom is also planning commercial partnerships for helium-3. In May, the company announced a deal with the U.S. Department of Energy to purchase up to 3 liters of helium-3 by 2029. Simultaneously, Interoom signed an agreement with quantum computing startup Mabel, which aims to purchase thousands of liters annually from 2029 to 2035. These developments mark a bold new era for lunar exploration, combining scientific discovery with potential energy applications for Earth. This highlights that helium-3 has valuable uses beyond nuclear fusion, including quantum computing, national security, and medical imaging. While some helium-3 can be extracted on Earth, future demand will likely require lunar sources. Currently, Interoom is a small startup with around 25 employees, but it is positioning itself to become the first U.S.-based commercial lunar mining operation. Their ambitions go beyond helium-3. They plan to harvest industrial metals, rare earth elements, and water to support long-term human presence on the moon. The exact methods are not fully disclosed, but Interoom claims a patent-pending technology capable of deploying smaller, lighter systems that require 10 times less power than current alternatives. This promise alone has secured over $18 million in funding, signaling the start of what could become a lunar gold rush. If companies like Firefly Aerospace can provide reliable, affordable landing platforms anywhere on the moon, commercial resource exploration is likely to follow closely. For now, scientific exploration remains the priority, but make no mistake, there is money on the moon, and people are determined to find it.